Morning, Collision. And hi, Jordan, Tessa, and Blake. Thank you so much for joining us for this session.
Absolutely.
And we just dive in. As the title suggests, there is an old saying in the tech industry that hardware is hard. So why don't we start by talking about why that's true, assuming you agree with that, and why, even though it's hard, you're all choosing to pursue what you were doing. Maybe starting with you, Blake.
Yeah, absolutely. So we build public safety drones. So devices designed to get eyes and ears in dangerous places. This is largely challenging, I'd say, because number one, we have to develop an immense amount of autonomy software, autonomy hardware in order to make this thing function in the operating environments where it has to fly around. But it's secondarily difficult because we also have to be NDAA compliant, meaning that we can't utilize any electronics from China. Which is a major issue because the entire global drone supply chain is really based out of one city, which is Shenzhen. So when we go to develop one of these systems, we have to design and manufacture custom motors and camera systems and radios, flight computers, and kind of do all of that from scratch, which adds some complexity.
So by definition, you're bringing some of this stuff back to the US, whether you want to or not.
Yeah, we are forced to. But yeah, I think it's also strategically a good thing. As we're seeing in Ukraine, they're consuming 10,000 drones a month right now. If the United States wanted to scale up to that production, we just couldn't. So we're doing our best to sort of build out that supply chain here stateside for public safety use cases and every other use case that makes sense.
Tessa, tell us about what Dusty is up to.
Dusty Robotics. We build robots for the construction industry. Our robots are solving one of the biggest pain points in construction, which is taking the digital building plans and bringing them out onto the site so that people can build off of them successfully and accurately. And so we are actually creating the most accurate mobile robot on the planet right now. 1/16 of an inch accuracy, working in an unstructured environment. The reason I think hardware is hard is because you don't get a lot of shots on goal. It takes a long time to build hardware, to bring it to production, to even get it to the point where you can actually try it in the real world and see if it works for your customer base. And the reason I think that hardware startups often fail is because with venture funding, you don't get to try a lot of times before you can iterate your way to success. So you got to get it right the first time.
Kind of hard to move fast and break things when you're designing a physical object that you can't iterate on all that quickly.
Exactly.
Jordan, tell us about Standard.
Yeah, we build computer vision or cameras that are computer vision powered for physical retail, and we install cameras in the store, and we use that to sort of digitize the space so that we can understand everything that's happening, where shoppers shopping, where are they taking things. You can use that to deliver great experiences for the shopper. We call autonomous checkout. You walk in, walk out, get your receipt automatically, but you can use it to improve your operations and logistics inside of the store. We know when out of stocks are happening. We know when there's low stocks, when there's planogram compliance issues. So it's really about transforming a physical store, digitizing it, and taking it to the next level. And it has a big hardware component. It has a big physical operational component to it as well, of getting those cameras in. I think a lot of what you said resonates with me. You don't have a lot of shots at goal. And I think the other aspect of what we're doing is we're competing with technology that's decades old, which in some ways makes us have an advantage, but in some ways that technology is so ruggedized. And if you think about a laser scanner, like a point-of-sale system, it's so ruggedized you can kick it and it will never fall over. These new systems have to be as ruggedized and just as resilient.
Are you able to use off-the-shelf cameras, or is this required a lot of custom design work?
We do both. So we have commercial off-the-shelf as well as a internal development program for custom AI-powered cameras.
So you all knew what you were getting into when you decided to do hardware, but what have your learnings been in terms of, has it been even harder than you expected? We should probably also talk about the fact that, at least in some ways, I'm guessing it's easier to do hardware today than it would have been 10, 20, 30 years ago.
Yeah, absolutely. Like when you start a company, you want there to be some hard moats, right? Like, me personally, I want to do a product where if I do it, if I succeed, if the team is able to do it, then our moat is the fact that we did something crazy challenging. And so you know it's hard going in, but you never know how hard, right? Like once it really starts punching you in your face, you're like, I knew this, but now I feel it. So yeah, I think it's way harder than I thought. I still think it's great, and there's all these conversations in AI happening right now about what's your moat, right? Like you know, you're not the large foundation model, like so what is your moat? And I think hardware is an excellent moat. If you can get over that hurdle, you can win. You can capture and retain a market.
Yeah, totally. I would say one of the things we never expected was the supply chain disruptions in the past couple of years. You know, boats clogging up canals, unable to get materials from suppliers. Some of our part lead times are upwards of 2 years.
Wow.
And so it's really hard to build a startup if you have to wait 2 years to get a part. And so it's forced our team to be very creative about how we're actually building the software, the hardware, and actually stockpile parts, become like a parts inventory supplier ourselves, so that we can actually build the things we need to build.
Blake, there are some really large, extremely well-established companies that do public safety tech. Does that make it easy for them to do what you're doing, or is this an example of something where being a startup is actually helpful to the cause?
Yeah, I mean, I think one advantage in our industry is drones are just hard to build. Like, they're fundamentally challenging to manufacture, to make reliable. I think the big incumbents in our space largely don't want to build a drone. Like, they don't want to take on that hardware component. They're very interested in building out software solutions that might integrate with off-the-shelf DJI drones, for example. But yeah, for the most part, they just really don't want to take on the hardware lift. So we're grateful for that. Good sort of universe for us to exist in.
DJI has like an incredible percentage of the drone market, both for the consumer ones that some of us are familiar with, but also enterprise stuff. And it seems like that inherently presents challenges to anybody else who's trying to compete in that market.
Yeah, I mean, what's kind of unique for our industry is the United States federal government has banned itself from purchasing Chinese-made drones. So that applies to DJI, it applies to Autel, it applies to Unique and some smaller manufacturers. You add up the market share of all of those companies, we're talking, you know, well into 90, you know, maybe 95% of the market these types of companies own. Which is fascinating because basically the largest drone manufacturers on the planet, these big Chinese companies, cannot sell to the largest drone buyers on the planet, which is, you know, US federal government and public safety and critical infrastructure. So there's really this need for like a drone maker for the free world. And yeah, that's kind of what we want to become.
You've all been doing what you're doing during a pandemic when remote work became mandatory. What does that mean for companies that inherently have a physical component to what you're doing, and you can't just work in the cloud and accomplish everything over Zoom?
I mean, in some ways, it forces you to do the right thing from the beginning. When you deploy the hardware, it's going to be in the field, and it's not going to be sitting on your desk. It's not going to be in your hardware lab. And when you're talking to your hardware team and they're complaining about, well, how do I just like plug this thing in? How am I going to debug it? And you're like, well, what are you going to do when it's out in the field? So I think it kind of forces you in some way to develop those best practices, but you still have to have some moment where it's tangible. It's, you know, you're able to literally rip it apart, do a teardown, and that, I think that's challenging. So you can get over it by using capital and just buy a drone, buy a camera for every one of your engineers so it can sit on their at-home desk. But I think at some point you also need to have some physical space. We're 100% remote, except for the fact that we have a hardware lab.
We actually took a contrarian view to this. We never went remote. We actually formed a pod, you know, back in the early days of COVID. And so we've been in the office pretty much since 5 years ago when we started in 2018.
Wow.
That made it hard, right? Because the rest of the world is going remote or hybrid or something. Makes it more challenging to hire people who want to be in the office. But we believe that we're creating a really good culture of people who thrive on the energy of actually being in the office with people, other people who are all striving to accomplish the same mission.
We've done the same thing. It's hard for, you know, a mechanical engineer working on a drone to be effective without access to the drone or access to CNC machines and 3D printers. Same for electrical engineers working on boards needing, $100,000 oscilloscopes, right? It's hard to send every double E an oscilloscope for them to do bring up on on a board. So yeah, we've just sort of been based out of a centralized office.
You can't build a robot in your living room.
Yeah.
Not until the robots can build themselves.
Someday.
Did you run into any gnarly supply chain issues? And if so, have those gotten back on track more recently?
Yeah, I mean, Brink has always existed in this climate of chip shortages and so forth. So one thing that we've done a lot of is just risk buying components. So if an electrical engineer identifies 5 critical pieces of silicon in order to make a board work, before we even design the board, we'll buy production quantities of those 5 chips. So we know that by the time we invest all of that engineering effort to make the board work, we're going to be able to produce the thing. So it's really excruciating to be in a position where multiple electrical engineers are working on something for a few months. Then you realize you have to throw all of that away because you just can't buy the chips. So that's been our strategy. It's worked pretty well. So I think there are some strategies you can implement to kind of mitigate risk in this area.
So for us, we've actually had to buy up a large number of components unexpectedly just to mitigate the supply chain risk. One of the things I did not expect was having to store all of those components.
Yeah.
And so we actually need a lot more office space than I thought we would because we're actually serving as a parts inventory supplier as well. But the other surprise for me was when you have an 8-month lead time on some of your most critical components, you have to forecast out a lot farther on the sales side than you would otherwise because you need to order those parts now for delivery mid-next year so that you can actually meet your sales forecast. And once you've got that product market fit and you're starting to scale up, you really need to start doing that planning ahead. And the supply chain risk just makes it harder.
Yeah. Yeah, I mean, for us, risk buy is the name of the game, so we're definitely doing a lot of that. I think it's one more place where you can have a moat. It's one more place where capital can give you an advantage, and it's not so easy to come in and displace you. I think you two sounds like very hardware native, and we're a software company becoming a hardware company. So there's a very large cultural shift that we have to go through, where 90% of our DNA is software, and you want to be able to just make a decision and change it tomorrow, and then change it again tomorrow, right?
Yeah.
And the fact that you need to plan 8 months in advance or 12 months in advance is a massive cultural shift, and it's really hard to get not just your engineers, but your entire org to start thinking in that way and thinking about where, they call it risk buy for a reason. Where are we comfortable taking this risk, and where aren't we comfortable taking it?
I've struggled with that a lot. I think naturally I very much want to be iterative in product development. And if you're spinning custom boards and writing an immense amount of custom software and everything else that's hardware specific, you can't really do that. You sort of have to get it right the first time. We were just talking about this, but trying to iterate 3-5 times on a new drone system, it just makes it unviable to develop these types of products.
Yeah,
so it's definitely challenging.
And you've got to inject, go ahead.
There's another cultural shift that we're seeing, which is that the flow of building hardware is that you build the hardware first, mechanical, electrical, then you build the software that runs on top of the hardware, and then by the time you get to the software part, your mechanical and engineering and electrical teams are wondering, what do I do? So you have to have the next product lined up, and you have this pipeline that you need to start filling with product ideas. So you have to think a lot farther ahead as a hardware company.
Absolutely, yeah. Some of my background is in, I used to be a federal employee running teams in the federal government, and they force you to do SDLC, software lifecycle, in a certain way, and it's very waterfall. And one of my mentors at the time was like, Jordan, the government can only build rocket ships, right? Like, we've taken that mentality and we've applied it all the way down to even what we're doing, which is just pure software. But I think that's actually a really valuable skill to learn. I hated it at the time, but now it's like, actually, sometimes you do need to plan ahead, and it's exactly these types of situations where you've got to keep the pipeline warm, you've got to know what everyone's doing at all times.
Even in great times for the startup economy, it can be difficult to raise money for hardware. VCs, after all, love the fact that software is eating the world and hardware scares them. How much of a challenge of that was that for you? And in the current economic climate, how have you done in terms of having the capital you need to keep on doing what you're doing?
I mean, one of the things that I've seen is a shift towards more interest in non-SaaS businesses. You know, SaaS has gone through a bubble, I would say, and now there's the question of, well, what's coming next now that that bubble is kind of imploded? And so we're actually seeing a lot of interest in build world technology, right? Companies that help build the buildings that we live in, because that doesn't go away. That doesn't crash when the market goes south. People still need houses, they still need conference centers, and all of that still has to happen.
Right?
Yeah, I mean, this is a real dynamic, but one thing I think is amazing about hardware businesses, especially in the public safety industry, but in many different industries, is that the stuff just really matters. You know, like the alternative to what we build is a dozen police officers holding assault rifles, making entry into a structure, and risking a gunfight. In the future, we're interested in this idea of, you know, making the police helicopter obsolete, using drones to respond to 911 calls in seconds, you know, deliver ADs, EpiPens, Narcan, that sort of thing. And I just think like the positive societal impact of the right hardware technologies can be enormous. And you know, I think a lot of investors are, to some extent, looking to have that sort of positive impact on the world. I mean, obviously, they're looking for returns, but they want to do good. And I think hardware enables that in ways that software can't always match.
Yeah. And I think, you know, fundamentally, when you're taking a bet, when you're making an investment, you're looking for a massive TAM, and, you know, I think we all have massive TAMs. Retail is this $25 trillion industry, but you also want to have some assurances that if you get over the hard hurdles, that you win the market. And I think hardware is just one more way that you're putting up those hurdles. It is harder, but if you get past it, then you could potentially be the single player that was able to capture and revolutionize that industry, which is why it's such an attractive bet.
We're almost out of time, so let's end with a flash round. If we could get maybe one super quick prediction from each of you for the future of hardware.
You know, for me, it's about how do we get AI closer to the sensors itself. You know, computer vision is, you know, it's in some ways it's been around for a long time, but I think it's still nascent, and I think we can still reduce latency. I think we can still get bigger models that are able to get more insights and put it as close to the actual pixel sensor as possible. Why am I detecting this photon and then doing a bunch of processing and then shipping it over to another processor? Like, let's just process it as we detect it.
Tessa?
For me, it's about robotics becoming as ubiquitous as electricity. You know, right now, robotics is kind of like a frontier tech, but the technology is getting better and better, it's getting easier and easier to deploy, and eventually it's going to be in every single product. And when that happens, it's not going to be called robotics anymore. We're not going to be standing on stage talking about it. It's just going to be taken for granted.
Blake, take us home.
Yeah, absolutely. I think we're starting to realize that there are certain industries that have such extensive national security implications for our country that we just have to own them internally, like chips, like drones, like many different things. So I think we'll see the kind of new generations of startups, hardware startups in each of these areas, starting to onshore that technology in the next couple of years.
Yeah.
Thank you so much, folks. Good luck to all of you. Hopefully we'll get to continue this conversation. And thank you, audience. Have a great collision.
Thank you.
Thanks, Harry.